Hi everybody, my name is Emmanuel Giner and I am one of the main quantum package developers, and today what we are going to do is to make a video about how to run your first Hartree-Fock calculation on a bunch of molecules. Okay, let's go for it. So once that you have correctly downloaded, installed the dependency and compiled the quantum package, the first thing that you need to do is that you need to run the QPSH executable that opens a kind of bash session that we call the quantum package shell. Okay, this quantum package shell is exactly as a shell session, but in addition to that you have all the QP commands with the auto completion, which is extremely useful. So anything that you want to do, start with QP, and then with tab you have all the commands that you can access to within the quantum package. Okay, so said that, what we are going to do now is to actually run a quantum package calculation, that is a Hartree-Fock calculation on the HCN molecule. So to do the Hartree-Fock calculation, let's go somewhere in your file system. Okay, here, and here I have my HCN.xyz file, which is the geometry of my molecule in the XYZ format. Okay, so then what I will have to do is that I will have to create an SVO folder from the XYZ file, which means that I have to create a database called the SVO database, which contains anything that you can possibly imagine regarding a quantum chemistry calculation. So it can be the number of electrons, the geometry, the AO basis set, and any of these things. Of course, as it is a little bit like a bash command, but within the QPSH, you have this -h, so for help, of course, that can really help you to know how to use a command. So it's really exactly as in bash. Okay, but today we are not going to go through all the -h command, and what we are going to do is that we are going to just use it. Okay, so we have this HCN.xyz file, which contains the HCN molecular geometry, okay, in the XYZ format, and what we are going to do is to create the SVO database regarding the Hartree-Fock calculation. So to specify a Hartree-Fock calculation, okay, what we are going to do is to specify the basis set, and let's go for the 631G basis set. We are going to specify the multiplicity, that is a singlet, and then of course the file. Okay, so if you do so, what do you see here is that you have now this file hcn.svo that has been created. Okay, and this folder here contains a lot of folders inside which contains everything that you can possibly imagine in terms of keywords or things to store. For example, if I go here in the AO basis, okay, I have things. So for example, if I try to edit AO basis, I have 631G. If I have AO num, for example, I have 20 orbital, that's the number of AO functions, and so on and so on. One thing that is important is that, for example, here I don't have such a thing as a MO basis, because if I go tab, I have nothing here, and that's normal because we didn't run a Hartree-Fock calculation, so we only have basically the number of electron, the nuclear geometry, and the AO basis. And now the next step is the Hartree-Fock calculation. But before that, the last thing I want to tell on the SVO database is that you see that here you have this HCN.SVO that is a kind of cat. Okay, put here. This means that any command that you will run from now will act on this HCN.SVO database. So if when we will run Hartree-Fock calculation, for instance, this will modify this SVO database and create the MOBasis directory. Okay. So this is what we are going to see now. So let's go for it. How do you run an executable on an SVO folder? Well, what do? Is you simply go qp run, okay, here, and then you tab. And what you see here is, for example, you have the SCF here program, okay. But if you don't know what does the SCF program, what you can go is you can go for qp man for manual, of course, and then the name of the executable. And if you go here, what does it do is that it prints out a kind of man page of the program. Okay, so for example, the SCF program performs a restricted Hartree-Fock calculation, and it performs the various thing that is here, and it used the DES algorithm and blah blah blah, and so this is just to show you that you can really use a lot of commands with the quantum package sh as you would do for bash. Okay, so said that, okay, when you have this qp run scf, okay, and you have this hcn.svo folder, as I said before, this means that the scf program will run on the SVO database. So it means that it will look for the AUBasis within that SVO database, number of electron, nuclear geometry, and so on within that SVO database, and then it will run Hartree-Fock calculation and then create an MOBasis in that SVO database. Okay, so you do qp run scf, and then what you do is that, for example, you put the output somewhere in a file. Okay, so it has run, perfect. If I just look what's inside, okay, so this is the output of the SCF program. So it prints out a lot of things. Okay, for example, that you're running a quantum package, that's the date, the git status of the program when you're running the job, what is the SVO directory you're running on, and a lot of things, then the geometry of the molecule, and then at some point it tells you that it is computing the AO, electronic integrals, and blah blah blah, any kind of things, and then it performs the SCF iterations here, and then finally, when it has converged, the eigenvalues, okay, of the Fock operator, then finally the SCF energy. Okay, so once that you have done that, what you know is that you have a Hartree-Fock calculation run on that SVO, which means that, for example, if I want an SVO here and I go MOBasis here, I have something now, okay, which is not the case just a few minutes before, because now the output of the SCF program is the creation, or in general the modification, of the MOBasis directory within the SVO database, which means that it will here have created the MOBasis directory. And for example, if I go for ammonium, here it has 20, and if I go, for example, MO label, it tells you that it is the canonical orbitals. So to conclude this video, I would say that what we saw was the QPSH that allows you to benefit from the bash type environment, but within the quantum package, so with all the QP commands. Okay, so we saw that any command has a man page, okay, either with qp man the command or qp command -h, okay, case a equal kb, Then what did we see? We saw that so you start from an XYZ file, then with qp create SVO you create an SVO database, and that SVO database can be further modified by running a Hartree-Fock program, for example, that will create an MO basis. That's very general, okay, as we'll see in later on videos. So said that, I hope you didn't get too much bored by this video. Many more are coming in order to try to play, and but the key thing is that you really have to play with all these commands, and you won't do anything wrong anyway. It's just quantum chemistry, so it doesn't hurt. So just to play around, okay? So said that, see you soon. Ciao.